Hello guys, and welcome to our channel. In this playlist we are going to explore the concurrent programming, but with a unique idea. So we are going to do some concurrent programming with Golang and then try to do the same thing with the Python. So from that you can clearly describe and see what's going on with Golang versus the Python. For that reason, I grabbed and found a nice YouTube guy. His name is Donald. I'm just going to go based on his idea. So he has this Go playlist with 26 videos, and the second and third video is about the concurrent programming in the Golang, and I'm going just to grab his idea and further improve it based on his implementation and explanation. I will put his playlist and the username in the video description, in our video description. Let's start. So what Donald tried to explain is just the order and refund process of say some e-commerce implementation or some sort of thing. So if you don't know Golang, just do not panic. It's not important at all here. But what we have here is a function, the main function, where we call the process function, and inside the process function we have this loop which is just incrementing infinitely, and it has a sleep like 0.5 0.5, right? And let's just run it. Let's see what's going on here. So go run main go. So processed order 1, processed order 3, and it's continuously just processing the orders. And how about if I want to refund the ordered products? So we are going to call with refund, and again run. So as you see, it never catches this refund function because it's just continuously running inside this infinite loop and never ends up to call this process refund function. That's the problem of the concurrent programming. So actually the simplest way. So in Golang, it's super easy to achieve this concurrency. You are going to just add this Go keyword in front of the process, the function, and if you run, so now if you see, like, it's refunded, ordered, refunded, ordered, refunded, ordered. So it's just switching between this the functions. And this is actually how the base concurrency achieved from the Golang side. Let's see what's going on the Python side. So with Python, we have this the process function again. It has the for loop inside, this time sleep, again the printing the processed item, and we have also the main function which we are going to run here. If we run, so process 1, process 2, process 3, and etc. So it's the same thing. If you try to refund here and rerun, it's never catch this refund the function, because again it will go through all the range, and whenever the for loop ends, it's going to process the refund. So that's not the case we want. Unfortunately, in Python, it's not easy as Golang, and we need here to implement this idea for concurrency. We need asynchronous programming, so we need async IO. And let's just start to implement the same idea with the Golang. So as you see, we want with Golang we want so refund order, and the same thing we want with the Python. But before this, we need to make this iterator actually as a generator, and it should be the asynchronous generator. That's why we are going to, first of all, to import asyncio and define this async generator. So async def async generator. It's my async generator, and it's going to it's going to range from here. Then it's going to yield our I, and of course we need to I think the sleep here, and actually await for this. Why we are not using time sleep but async sleep? Because the time sleep is blocking action, but awaiting the async sleep is asynchronous action, non-blocking action. That's our async generator. We need to make this process. Just scroll down here. This process function as well, the asynchronous. So make async def process item, and now we are going to not range, but we are going through this async generator, which is what's the problem here? It should be async for. Great, and we do not need this the sleep here. So what we did, we have created this async generator. We have created this async process the function and asynchronous for loop going through this asynchronous generator. What we need to do further to achieve our concurrency, we need to make this async the main function also asynchronous, and just register this functions as tasks, which is going to make them the features. So prior to Python 3.8 version, there is an ensure feature, but this is I think IO create task is a preferred way to do asynchronous programming in async IO with recent versions. And we have second task, which is refunding. And then we need to await these tasks, and we need to async AO run our main function here. As you see that we nearly rewrite all of our code in order to achieve the concurrency here, but still it's quite straightforward and neat. So again, just go through the code. We have generated the async generator. We have this process function with async for loop going through the asynchronous generator, and then we have a main function where we are registering actually our functions to be executed in the event loop. So if we run now this function, as you see, this refund order, and it's nearly smooth, like 20, 21, 23 order and 25, like it's going to the same amount. It's nearly similar to our Golang. So as you see, order refound, order refound, refound order. But with Golang, it's just for some time it's just switching refound and the order. But with our Python implementation, it's the same thing. So we have achieved our first the plan. Actually, we did simple concurrent programming with Golang, and we did the same thing with the Python. In the next video, we're going to continue our talk about Golang concurrency problems, design patterns, and we will try do the same thing in the Python as well. Thank you guys. Thanks for watching. See you in the next video. Hello guys, and welcome to our next video about concurrent programming, the Golang versus the Python. So what we are doing here, basically, we are defining the problem and trying to implement the same idea with Golang and the Python. Where we left off, so in the previous video, I'm going to change the stop section to increment like until 5, and let's see. So we are doing processed refound and the order exactly 5 times, and this is where we left off in the previous video. What do we want to do here? We want to make an extra process with the cancel, as maybe we want to cancel the items, but what we want to do is like to run the order and refund 5 times, and only after that run the process of the cancel. So this is the problem definition. What we can do here, like maybe we can do 2 Goroutines, and after that run this cancellation process. Let's see. Nope, it doesn't work, because as we see, it's going to cancel order refunds and refund order cancel, so it's going to process all of these things concurrently. We don't want this. We want like exactly 2 order refund thing concurrently running 5 times, and 5 times running the process the cancel. This is basically a synchronization problem in concurrent programming, and for this one possible option to implement this feature is using the wait groups from the sync package in the Golang programming language. Let's implement. So var vg sync wait group, and of course we need to import this package here. Then we need to add a 2 here, because we want to wait for exactly this 2 Goroutines. That's why we are going to add the 2 here, because we have 2 Goroutines and we want to wait them. But prior to this, we need to define this process order and refund inside the anonymous function. That's why we need to run like gofunc. This is a signature, and then add this process order inside this function and call this function. And of course we need to notify the Goroutines that we are done with processing the order. That's why we're going to call defer vg done here. So the defer statement is going to be called only after the processing the order. Yeah, the same thing here with the refund. and of course, and of course VG done. We are basically notifying that we are done with this implementation. So let's see what's going on here. Let's run. Yeah, we didn't call this. Still the same problem exists here, because we need to wait here for this Goroutines to be exited. So that's why we need to add VG wait. So let's see if it works. Still the same problem, because we put the VG wait in the wrong place. So we need to put here. And let's see if it works now. So let's clear a bit screen. Refound, order, refound, order, refound, and cancel, cancel, cancel. Voila. So that's it. Let's just increment the wait sleep time in order to see it's refound. Okay, refound order, refound order, refound order 5 times. Then 5 times it's going to run the cancel. So this is basically the implementation in Golang, and as you see, it works. Let's see what's going on with the Python side. I'll just scroll it down. With Python, we need to make some changes here as well, but let's do some the cleaning here. I want to take this await sleep from the asynchronous generator to sleep statement, to the process asynchronous process call, because it's much similar to the Golang's process. Here it's sleeping, and we need to do the same thing here. Let's say we left off, and also I need to change this if we want 5 times, and also the sleep to a second. So let's see. Oops. 1. Okay. So process set order, refound, refound order. Well, that's basically where we left off. And what we want to achieve here, the same idea, but with the async IO. Let's just try to do same wrong things. So if you want to create this as a task and a task 3 and cancel, and if you run it, this is exactly the same thing what happened with Golang. So it's run the concurrently, also the cancel. We don't want this to be happen. We can actually await directly the process cancel process without registering it as a task. Let's see. Order, refound, order, refound, order, refound, and the cancel. This is the one possible way you can do here, but another possible way is using the similar to the Golang's statement. Another possible thing is using the wait, async IO wait. For that, we need to register this task 1 and task 2 in a list, and then just await async IO wait, and wait for tasks, and also return when, and we want to return from this Goroutines tasks whenever first is completed. And so let's see if we can achieve the same result here as well. Yeah, order, refound, order, refound, and 5 times the cancel. So amazing stuff. So we can do the same thing like in two ways. One is registering upper two available asynchronous function, I would say, as tasks and directly await from the process. Another possible option is just using this wait and returning from the first completed and then awaiting directly the process cancel. So basically we have achieved our statement and fixed our problem. And I think that's it for this video. And yeah, see you in the next video. Bye. Hello guys, and welcome to our next video about concurrent programming. Our idea is simple enough. We are going to do some concurrent programming in Golang and then implement the same thing in Python as in the previous videos. Today's topic is rather important, and it's about communicating between concurrent components. So as you expect, the most part of the concurrent programming is sharing something between threads or concurrent components. With Golang it has its unique approach, and for me it's most elegant one actually, and let's see what they have written about this. So the topic is from blog GoBlog, and the name is Share Memory by Communicating. And let's just read through to get the base grasp of the idea. So the traditional threading models commonly used when writing Java, C++, and Python programs, for example, requires a programmer to communicate between threads using the shared memory. And whenever you share something, you need to protect it. That's why typically shared data structures are protected by locks. You can hear something like lock, mutexes, semaphores, and something like this is a synchronization primitives that just protecting the shared component from some kind of I don't know, overusing or abusing, if it's okay to say, and yeah, content over those logs to access the data. But Go's concurrency primitives such as Goroutines and channels, so the channels is a new thing for us, to provide an elegant and distinct means of structuring concurrent software. So the Golang's approach is using the CSPs, the Communicating Sequential Processes algorithm, and instead of explicitly using logs to mediate access to the shared data, Go encourages the use of channels to pass references to data between Goroutines. So what does it mean? It's just kind of there's a channel. The imagine is like pipe. You some Goroutine, they're putting some data or just sending a reference to some memory object, and from another Goroutine you can read this. So that's another end of this pipe. You can read this sent data. And this approach ensures that only one Goroutine has access to the data at a given time. So there's no need for logs, because you can only once put something in the channel and you can read at the other side it will read through the channel. And the concept is summarized in the document of effective Go. So do not communicate by sharing memory. Instead, share memory by communicating. So in the next video, we are going to implement we are going to write some simple Golang code with using the channels, and then we are going to implement the channels in Python using the asyncio built-in methods. So there's no such built-in thing in Python for supporting this CSP. The only thing we can do here, like write some wrapper or simulate this channels effect using Python's asyncio. That's it. It's the intro to the Golang's another concurrency primitive to channels. We have seen this Goroutines and also the weight groups in the previous videos, but now we are going to explore these channels and implement the same idea in Python. So that's it for now, and see you in the next video. Bye. Hello guys, in the previous video we have introduced the Golang's channels concept, and now, yeah, it's a coding time. Let's just dig into. First of all, I'm going to remove all previous code with the weight group things. In order to create the channel, the object, I'm going to use this channel type. And it will accept, actually, you can put into this channel as the string type. So the next thing is called Goroutine with this process method, but we need to pass this channel into this function. And of course we need to accept this here. The next thing is to put something into this channel. I'm going to write like FMT, this put message that I'm done with putting. So put that, and put item. Then I'm going to put this item, this passed item, into this channel, and then just get rid of this FMT and fix time sleep. So we put this item into this channel, and after we return from this Goroutine, we need to read some data from this channel. For this, actually you can range over the channel in Golang, and you can print the value from this channel. So what we can do here, like processed, the past item processed. No, processed, right. Let's see what's going on if we run this code. So go run main go. So it's important and not we don't need this sync package here. So puts the order, process the order. Oops. So what we see here, we put the order to the channel, then we're going to sleep. It means that we need to go back to the main Goroutine. It's going to range and reads this item, and as we pass this the orders, so puts the order, process the order, puts the order, process, and it will happen 5 times, but then it will give a fatal error here, like all Goroutines are asleep, and a deadlock error here. The thing we can do here, and we need to do here, that after passing and passing everything to the channel, we need to close this channel. So I think like it should be fixed right now. So puts the order, process the order, puts the order, process the order. Easy. In Golang, like, it's really easy to communicate between Goroutines using these channels, and I think this channel type actually is the most powerful, one of the most powerful types in the Golang itself. So let's just summarize what we did here. So we run a for loop, put the item. Item is an order string for us. We put this item as a channel. then we're going to sleep. It means that go back to the main. Then we are going to for range through this channel. We found that it has this item, then print it. And going back, again, it's the second time that putting this item. So puts the order, process the order, puts the order, and the process order. And whenever like we end this for loop, we are going to close this channel, and it means this range will also exhaust, and there is nothing left inside inside the channel, and it means we need to exit from the for loop as well. This is a Golang part, so it's super easy, as you see, but we are going to implement the exactly same feature, and we want to get the exactly same output from the Python as well. And I'm going to implement the Python code in the next video in order to make this video short enough. So see you in the next video. Bye. Hello guys, and now it's time to implement this channel style concurrent programming with Python. So just let's start by creating this channel type and also this Goroutine type in Python. So I'm going to create new Python file called channels, and it should have of course that we are going to import this async IO, and we are going to create this class chan, and it will have the constructor with buffer size 0, and we will explore the bufferized channels as well, but just for simplicity we need to have this thing here. And I'm going to create like self channel with async IO queue, and max size here will be the buffer. What happened here? So what we have to do is we need to put something to the channel, and we need to get out from this channel. So we need to define this async function put, and we need to pass value, what value we need to put here, and await this self channel put with this value. Another thing that we need to get value from the channel. That's why we are going to return and then await the self channel get here. One thing to note that if we have the empty channel or empty queue for us here, that means that we need to return none. So if self channel empty, it will return true if it's empty, then we are going to return none. So nothing left actually in the channel, so there's nothing in the channel. And in order to implement the iteration, asynchronous iteration through the channels, so if you remember, we need the same thing here. So for making the channel type, we are going to write the channel class and create object from this. For making a process as Goroutine, we are going to implement another class, but for ranging through the channels, we need to implement following methods. So first of all, this aiter, and it should return the self. Then we need to have a synchronous next method and value of this that we are going to await from self get, which is this method. And if val is none, if value is none, which indicates that we are returning none explicitly here, we are going to raise stop async iteration, not stop iteration, but stop async iteration, because this is asynchronous if we are going to use inside the asynchronous for loop. And until that a queue or channel is not empty, we are going to return this value here. That's it for channel type. Actually, it should work. Another remaining is that we need to create this Goroutine class with only this static method like go, and pass. It will accept coroutine, and we are just going to create task from this past coroutine. Let's use it inside the main function. So what change we need here? Like we need to remove all the things. Another thing we need to do here, we don't need this item anymore, and I'm just give a placeholder here. Then we are going to put something to the channel. So of course, we need to accept this channel first. Yeah, and then C to put the past item, and of course we need to print this put the item, and then slip here. So this is a for the process. This is similar to this thing. So we are going to print and then go to we send here the item to the channel. We did the same thing with the Python as well. So where is it? Right. So we put to the channel, then print, and then slip. The same approach with the Golang. So we need to import our channel from channels, import chan and Goroutine. Easy. So C is chan and calls this go with the process and pass the order and created channel object to the go. So this is a similar thing with here. So we created the channel type, we pass the process to the Goroutine. So Goroutine go process, and again we need to slip here. Oops, wait, async io sleep, and then we need to synchronously for over the of the channel, and then print processed item, and then again sleep here. So what we did, as you expect, so we have the range here, for loop here going through the channel. Same here, we have a for loop going through the channel where we put some items, and then we just print this, and then the sleeping, awaiting the async io sleep in order to get back to put another item, then just get to the main function and read another item from the queue or from the channel. And let's run it. We will see if it works. So puts order, process order, puts order, process order, and it should be the 5 times. So 1, 2, 3, 4, 5. That's exactly what we see with our go code. So put the orders and process the order, and the same approach here that we put the orders and process the order. So what we did so far, we implement our very own channel how to say, with using this async IO queue, we implement the asynchronously going through this channel, and also it's just wrapper to create a task with go name. This is for like for fun, like make it more similar to the Go code. I think we are done. So because we have the same output and the same features with Golang and also with the Python. So we'll continue our concurrent programming techniques with using channels, and again we are going to do the same thing with Golang and then implement the same thing with the Python. So that's it for now, and see you in the next video. Bye. Hello guys, and welcome to our next video about concurrent programming. Today we are going to introduce a new problem and show how to fix it in Golang first. And to describe the problem, let's just write some code here. Let's just get rid of this old code, so we don't need them, and start from scratch. So I'm going to create a 2 string channel and then we have 2 Goroutines inside the anonymous function, and we have this for loop where we are going to sleep for half of the second, and put some data, say order processed, into this channel. And I'm going to just copy this and put the same thing to channel with refund, but now the refund will take 1 second to finish. So this is a half of a second, and this is it. So refund process, it just takes more time to finish, takes long time to finish rather than order process. And we have another for loop where we are going to just print first of all this and then we are going to print the second channel value. So let's say ideally we want that it should process 2 times more order than refund, but let's see. Okay, so it's order process or no, so it's order process and refund process. So there's order process and refund process. As we see, there is no 2 times order processed. So this is called a bottleneck, and the Golang has a special syntax for dealing with these problems, and this is a select syntax. So let's just use it and see what's going on after that. And we have some code chains here, so I don't need this infinite loop. I need, like, again, this let's just make it for 5 until 5, and the same thing here for another for loop. And just get rid of this print lines, and let's use this select syntax. So select, in case of if something appears in the first channel, then fmt println this message. And if something appears first from the second channel, let's just print it again. But we need to figure out how to exit from this for loop and end the select cases. I'm going to use circle done channels. So you can use another channel to indicate that we are done with processing and processing orders or processing the refunding. So it will in type, and whenever we exit from this for loop, I want to pass 1 to the done channel. The same thing actually should go here, and we need to have some case statement for down value. And if we do some if something appears in the done channel, we need to decrement this n. And what's n? So we have 2 Goroutines, and I need only 2 here in order to exit from the for loop. So if the Goroutine to process the order 5 times here, then it's going to add 1 to the done channel, and it will match this case, and it will decrement. So n will be 1. Then if we finished with refunding the process, it will add another 1 to the done channel, and if we are going to match this done and decrement this, and because after the decrement it will match the 0, and 0 is not greater than 0, that means the for loop will exit. Yeah, that means the for loop will exit. That's the case. And let's run. If we see, well, so ideally we need to see 2 times order and then refund, 2 times orders and refund, or refunds and 2 times order. Reset. So let's see, order, refund, order 2 times, yeah, refunds and order. So let's see. So order 2 times and refund, order 2 times and refunds, and 1 order because this for loop, this iteration exhausted. Then with the remaining 3 refund is just going here. It's actually not 5 times, it's just 6. Oh, maybe we need to do like this, yeah. So, but still, it seems to me that we have fixed the problem. 2 times orders and refund, 2 times orders and refund 3 times. So 5 times refund, but because we are waiting less than refund process here, we can do 2 times the order, and after that the refund. So that was the description and of the problem, and we have fixed it with the Golang. In the next video we are going to do the same thing with Python. So see you in the next video. Bye. Hello guys, and it's time to implement the same thing we did in the previous video with the Golang. We actually use the select statement and run 2 times more order than refund, because it takes less time from the refund process actually. And now it's time to do the same thing with the Python. The Python async IO has no such built-in thing like select statement or something similar, but we can achieve the same output, actually the same work, by changing our code a bit. So let's just dig into the code and make some change. And the change starts from changing this process, asynchronous process method. We need to add this sleep time, the argument, and pass this sleep time to this process, the method. Yes, and we don't need to to print this because we have the different output here. So we need to order process and refound process, and that's it. But what we need here in other the asynchronous function, which is going to process the channel, and it will accept the channel itself and sleep time as well. And then we are going to asynchronously for in the past channel as we did previously. So we are going to await here for sleep time, for given sleep time, and print this item processed. Another change should go inside the main function, because in the Go code we have created two channels, so we need to do the same thing here. So channel 1 and channel 2, and also we need to pass to create actually two Goroutines here with refund, but we need to pass as well the sleep time, and this is a half second, and this is a 1 second. Another thing, so we need to get rid of this here, and now so we have passed the process and order the channels, but it should be second channel, and it's going to add asynchronously the generated values, the item item into the channel 5 times here, because we have this range here. Another thing we need to do is just asynchronously also the process through this channel. So I'm going to create two tasks here, async io, so create task, and it should accept this C1 and same amount of the sleep time for the first channel. And also I'm going to create this the second process channel for second channel, and of course with the same amount of sleep time. And of course we have created tasks, and it should be awaited. So await task 2, and await task 1. Await task 1. Let's run if it works or not. So order refound 2 times order, then refound 2 times order, then 3 times the process. So this is the exact output. So order process and refound. Let's see. So order process and refound process, then 2 times order. Yeah, that's 2 times then refound, and 2 times order, and at the end 3 times refound. So amazing, great stuff. So what we did here, we have created 2 channel types. We have created 2 Goroutines. Actually, they are tasks in the background. And another thing that after we have added the same amount of items into the channel with the given fixed sleep time, we need to create another task which is going to process these channels, again asynchronously. and with the same amount sleep time. That's how actually we can achieve at the same functionality where we did with the Golang. So with Golang, it's using select, and whenever something appeared the first time that appeared inside the channel, it will pick it up. Here's the same thing, so it will do it actually the async IO's event loop handles this for us, so we don't need explicitly to show that hey, I need this 2 times order, because it takes less time than the refound action. So that's basically the same how we achieve the same functionality with Golang and with Python's async IO. And I think we are done for this topic, and then we'll see actually in the next topic what we have in my notes. So yeah, that's it for now, and let's see you in the next video. Bye. Hello guys, and welcome to our next video about concurrent programming. And today we are going to talk about some concurrent patterns. So what we want to achieve as a result, let me just run the code. You should notice that the processed values are just processed by pairs. So we have 4 values. Say we have a website and the 4 items, the shirt, shoe, and ring, and we need to apply some discount to this shoe as shown. So we have a sale going on. The shoes are half off, so we need to apply this discount to the shoe. But it takes a second, and we don't want to wait a second. Or we want to process other items during this sleep or during this second. And this is called the FanIn and FanOut the pattern. Yeah, by the way, say hello to the Donald, and I will put his explanation video in the description of this video. So as a base idea is we have the main routine, and then we have 2 extra routines fitted with the channel of this item. So fitted with the same items, these 2 subroutines applying discount and then sending back out to the one channel, and after that we are just processing this discounted and other values out this combined channel. This is the idea, and let's see the code how it's actually written. So we have item struct, it has price and category, and we have a function main, and we are generating and returning the channel through these items. As a gen function, just accepting the items, range through items, and putting back the readed items, the out channel. Then we are returning the out channel. So C is channel. Then we are running this discount function on this the same channel. So the discount is doing it has a Goroutine inside. We're just going through the items channel and applying the discounts and sending back the discounted value to the out channel. And then we are returning from this channel. So C1 and C2 are both also channels. Then we are feeding this FanIn function with these channels. The FanIn function using here the weight group, because we need to process as a pair, so we need to wait somehow. This is also the synchronization problem, and it has some function type, and we are just arranging over the path channel putting back the value again to the out channel, and we are running this as a Goroutine as well. And we have two channels. We are going through all of them. So, and as a result, we are returning the out channel, and as a result, we are just processing through this channel. And finally, we have such things that we have feed the same channel of the items to the different discount channels, then just combine them to the out channel, and running through this out channel, the result is as shown. Yeah. So this is the idea what we want to achieve with the Python async IO as well. So in the next video we are going to write a Python code based on our Golang code here. Yeah, bye and see you in the next video. Hello guys, and welcome to our next video. So now it's time to implement this FanIn and FanOut concurrent pattern in Python. So let's start. First of all, we need to store these items, and of course we need to import async IO, and also import this chant type, and store the item as a dictionary in Python. The next is this generator, so this is gen function. Let's do the same thing here. So we need to define this as asynchronous function as well, and it will accept the items. We are going to create get channel inside this gen function, and for in items we are going to put this item to the channel and return from this channel. Yes, the next step is adding this discount function, and I'm going to add this discount, but I'm going to implement this Goroutine part in this separate function. So we need to define async def apply discount, and it will receive the out channel and also the items channel. Then we are going to run the for loop asynchronously in this items channel and check if the category of the item is shoe, then apply the discount. Then we need to put this discounted item back to the out channel, and we need to await like sleep to simulate this discount delay. The next function we need to implement is the discount itself, and it will also accept the out channel, the items channel, and it will wait for apply discount with out channel and items channel. So the next function is this the FanIn. So but before that I want to we need to implement the asynchronous function for processing the channel itself. So let's just define it. process channel, just separate the things a bit. So out channel, it will receive out channel and the channel where it should traverse. So async for in channel and await for out channel and putting back this the value to the out channel. The next thing is the FanIn function. It will also receive the out channel and also the channels. And for channel in channels, we need to process this channel and after the processing the channel itself, we need to process output. So what we have here, so we are going to implement this processing the output as a asynchronous function, and we need to await not here in the main function but inside the FanIn function. So, and the process output is, I think, def process output. It will receive the channel, and the only thing that it should print, processed in channel, it will print the same string. So category, yeah, is processed category, and also the price is processed price category. Nice. And we are waiting for this function here with the out channel. So we put the values to the out channel in the process channel, but processing the output for this out channel. And of course we need to yeah, that's it. What we need to, like, we have FanIn, we have discount, we have gen, and we need to have what's this? Nothing. So we need to have this async main function. So the main function is just it's just, yeah, we need to create this channel as here, so calling this gen function with this dictionaries, So in fact we don't even need this list here, but just it's my mistake here. So yeah, we've passed the items to the gen async function. It will return the channel. We need to create extra channels, and another one. So, and then we are going to await and then gather the discount out 2 and C, then discount out 1 and then C, then await and creates a task. Scroll it, and create task from FanIn, right? From FanIn, and should receive this out, then out 1 and out 2. This is out channel, and this is the channels out 1 and out 2. Out 1, right? Yeah, there's nothing remained here, in fact, and the only thing that we need to call it. So if name is equal to main just async io run this main function, and let's see. Oops. Let's see what will the result. It's somehow not sleeping. Yeah, I think that we need to sleep here in order to achieve mimicking this parallelism. Let's see. First 2 and second, and we can actually check if they are the different channels. So the first 2 values are from first channel, and the second 2 values are from another channel. So just print the channel. Nice. Yeah, it works. So again, just run this main go. So first 2, then second 2, and we have achieved the same result. Let's just get rid of this print. We have achieved the same result. So first 2, then second 2. Right, great. What we can show here, just print this the length of these channels. Out 1 and out 2. It's just for interest. I don't know if it will show some. Yes. So the 2, it's gathered traverse the channel from the gen function, and put some random 2 items into this out 1 channel, and second 2 random values to the is out the channel. And in fact, if we can see what's the length of this out channel, the final channel, let's see, because we have already processed, we have already processed channel, and it will just end the channel and close the channels, and that's why the length of the channel is 0 here, but it's 4. We know it because we have printed the values. What is remaining here? I think nothing. The only thing that I want to show that I have added implemented the len as returning the queue size from this channel, and added some extra methods to this chan type, like it's for convenience, so they should be there. So we have support for synchronous iteration, and also for asynchronous iteration for this channel type. So we have achieved what we want. We have result as the same result as with Golang, and this is how we have implemented this concurrent pattern with Golang channels and Goroutines, and also with Python async IO. So that's it for now, and see you in the next video. Bye. Hello guys, and welcome to our next tutorial about concurrent programming. Today's topic is creating sequential download manager using Python, and as a code base we get the Golang code. I've been searching for a great tutorial about using concurrency in real world example, and I found one. This tutorial is from Muhammad Usman, so kudos to him, and he did a great job on explaining how to build a concurrent download manager with pure Golang. And I instead just divided his tutorial in two parts. The first part is building sequential downloader, and the second part is building the concurrent downloader. And instead of explaining the Golang code, I'm going straightforward directly to translate this Golang code to the Python. I'm going to put Muhammad's explanation video in the video description, in our video description. So you need to first to look at his explanation, and then just come back to this video to see how we can actually translate the Golang code to the Python code. If you do not want to watch the Golang video, then just go ahead with our. Let's just start and translate the sequential downloader Golang code to the Python. So what we have here, we have a type download struct. We are not going to do this thing with the Python. We are going to replace this with a dictionary in Python. And basically we have a main function. So let's just start by implementing this main function. It has no arguments. It has a start time. So for start time, I'm going to use the date time now. Then replace the microsecond with 0, and of course from date time import date time. What happened here? Oops. Time. Nice. Then we need to create this dictionary. So d equal to, and let's just paste it here. Nice. So what we have is the URL of the file which we are going to download, the target path where it should be stored, and the total sections. So the base idea is just we need to divide this downloadable file in chunks. At this time we are going to divide this file in 10 chunks of bytes, and we need to download this bytes, so chunks, concurrently. But instead we are going to download for now as a sequential order. Then we have this do function. So I'm going to call this do here with past dictionary. Then there is a totals seconds, and again date time now, replacing this microsecond part, then just subtracting the start time, and there is a print statement which indicates a download completed. So we're going to use fstring download completed in this total seconds and seconds. That's it. So this is the main function. Basically, then we need to implement, let's just grab it here, this do function. So def do, so first of all, the printing the making connection. So print making making connection. And again, too many typos here. Then there should be the get new request function. Just instead run it as a placeholder, but we will implement this get new request further, and it should accept actually this data, and it is a dictionary. So what we have next, we have this got section. I'm going just to post it here. So we are just printing this got the response status code, and this status code is must be actually 200 in order to understand that it's exactly the success. Then we need to implement the same thing here, so return errors. So if the status code is greater than 299, we need to raise as an exception as we did with Golang section. Then we need to get this content length header from the response object. Let's just implement this. So we got the response headers, it's a dictionary, and we get this content length key value size, and we print it as we did here with Golang. Nice. Then we need to initialize the sections, the chunks or the portions of the downloadable file. And what we have here, so we need to implement a list of lists in Python to make available as a placeholder. So first, let's just example, if file size is 100 bytes, our section should be like, so 0 to 10, 11 to 21, 22 to 32, and so on, so forth until this 99 section. And so we need the list comprehension ranging through the data total sections, and as we remember the total sections in 10, it should be should give a result as this one. So if we run the sequential downloader .go, so making connection as we want, the printing this thing, so the got response 200, the response status code, then each size is the total file size is this bytes. Then we have so we didn't divide yet, so we divided by 10. Each size is here, and this is the thing we want. So in Golang, we need to make a slice of integers and give a length. But with Python, we have such the function call. Instead, we are going to use this list comprehension. And again, we need to calculate each size. So each size for Python is, so we get the size, converted to int, and divided by 10, because the data total sections is 10 for now, for us. And then we are printing this. So the each size is this bytes, and the sections is this one. What else we need to do? Let's just scroll down. Yeah, we have this range for loop for updating our list of lists. And this is quite straightforward. I'm just going to copy this. We have translated this Golang to the Python as it is. And then again, we need to print these sections. So what we have here. So we have updated these sections by going through the each section, and we again need to update these sections with the chunks. So this print sections is this one. Nice. What we have and here with Golang, the last thing is that calling this the actual download sections where the download processes happen, and we just call it. So for index a section enumerate the sections again, and we are going to call this download section function, pressing their index, a section, and the actual data. Nice. So we didn't implement yet this get new request and the download section. We are going to do is next. So after the do function, we have this get new request. So with Python, we are going to use request package. So you need to install it. Just pip install requests. It is a de facto and the default the package that many people like using here. For get new request, so let's just implement it. So def get new request, and it needs the method, the HTTP method. It's a type string. The URL is a type string again, and the headers. The type is dict, and by default it's not. We are not passing any headers to the get new request the function, and the return type is requests response. So we are going to return the response from the request package, but first of all we need to just import. So import requests. Nice. So what we have here, I'm just going to copy my notes from my notes. So what we have, we are doing calling the request method, passing the method of the request, so post, get, head, any type. So here we are doing like get. This is a HTTP verb, and we are passing the URL which we need to get or post, and the headers, the updated headers, or you can get the response and set the header and return from this get new request. Great, and we have here this download section function where we are doing the actual download. Let's just implement it. Oops. So what we have, so the download section should accept the index, section, and the data. So def download section, and it has so index should be integer, and the section is list of lists, and it's a list type, and the data is a dictionary type. And but here we need to set the headers with that range. So we need to give the chunk range, the byte range, where we are passing to the get request, and it will get this amount of bytes. Let's just translate this code. So this code is basically this thing. So bytes, the first index, first value, and the second value. So we are passing with this one, and this is a chunk boundary. So first chunk and first bytes and the end bytes, the start bytes and the end bytes. Nice. Then what we have, headers, and we are passing this to the get new request with get method. So as we describe here, we are passing the URL the method and the updated headers to the get new request method. And we need to print this downloaded bytes for section. This is here. It's the equivalent here. And what we have is just print this. Oops. Just here. So the print statement is so downloaded the response headers getting this content length as here. So gets the content length, bytes, and pass the section index and the section itself. So the section index and section itself. Nice. Then what we have, we need to create this file. So we need to create this temporary file as the section TMP indicates. So I'm going to just create a file name, and give it the name. So section index, the path index, and TMP. Then we need to call with open this file name, and we need to write the bytes here as local file. Yes, and write the local file, write into the local file this response content. Nice, very nice. The same thing we did with the Golang. So we are reading as the response body, then we are writing to this file these bytes, and if there is no error, we are just returning the nil, so that indicating the success of the file download. And let's just test our Python, sequential Python downloader, and I think there is nothing left here, so we have totally translated all of the code, and just this removing this section files, and yes, there is no, and it's just the remaining thing is just adding this code as I want to directly call it from the IDE, so calling this the main function. Right, let's do the sequential. So making connection, get 200 the bytes. The output is exactly the same. It's just download completed in 8 seconds, and let's just compare. Oops, I removed this screen. This is exactly the same result with the Golang code. We send a GET request, we are making connections, there's a success code, we calculated the total byte, divided it by total sections, initialize a list of lists with the chunks boundaries, gave the bytes here, and started to download each section to the different, the appropriate file. So section 0, section TMP, let's just show the, yes, each section is given byte length, and just remove this age. So we have translated the sequential Golang downloader code to the Python using this using the request package. So the next thing is to add the concurrency to this Golang code and to do the same thing to the Python code. See you in the next video where we are going to do the actual concurrent run. Goodbye. Hello guys, and welcome to our next tutorial where we are going to continue building the concurrent download manager. And again, this Golang code is based on Usman's the concurrent download manager tutorial, so you can watch it first to understand the Golang code, and then go back to our Python video. So what's the difference between the sequential downloader and the concurrent downloader? So with sequential downloader, we have a for loop, and running this download section function in a sequential order. But with in order to add some concurrency here, we need to run this download section function as a Goroutine. So this is basically the code portion that we have changed from the previous sequential downloader.go. And the addition here is this merge file. So the idea is we have downloaded this 10 file, but we need to give the user only one file. So if you download this 10 portion, we are going to merge it into the one file. So what this merge file here is doing is just opening the file, reading the sections. So we have 10 sections, finding each file, and then writing to the opened file here, so to the target path. So the target path here is this file name. So you can change this file name, and it will just write to another different file. That's it. And then let's just do this concurrent run. Go run concurrent go. As you see, the sections are no more sequential. So it applies some concurrency with Goroutines, and at the last it's just merging each file into one file. So let's just check if this file is here. Yes, we have this merged file, and the size is 5 megs, and that's exactly what we want. Now it's time to translate this concurrent code, or do the same thing in Python using asynchronous techniques. I'm going to close this this thing. Nice. And now it's time to start with Python, but to make it fully asynchronous, we need to redefine our architecture. And I'm going to start from the main function here with just if name is equal main, then we are going to create this this struct, the dictionary here. I'm going to pass there's an empty list of the tasks where we are going to store this where we are going to store as asynchronous tasks, and as a final note we are going to run this main function. We are going to implement above, and the merge files, where and the latest addition, this merge file, we are going to implement in the next. So that's it. Let's just start from the main function. So this main function should be asynchronous, then it should be async def main. It's going to accept this data is a dictionary type. It's going to accept a list. This is a list type, list of tasks. And again, the start time and end time. And returning these sections. So we are going to but now we need to import not request model. We are going to use this aiohttp and async IO. Nice. With aiohttp, let's just run it here. So we are opening the aiohttp client session as a session. We are updating this do function. So for asynchronous code, we are going to make the Python's do function here as an asynchronous code, and it will return this collected tasks and the sections. So then I'm awaiting here with asyncio wait for awaiting the completion of this task. So from datetime import datetime. So if we have next function, the do function, again it should be asynchronous. So the signature of this function is, so it's accepting the dictionary, the data is accepting the session is the client session type from aiohttp, and it's accepting the task as a list as described here. And it returns a tuple, list and list. So we are going to return from this do function the sections and the tasks. So task is a list and the sections is a list of list also. So it's a list type. And this is the standard things that we did it previously. So making connection and doing this get new request. But now this get new request is also the async code. And but the signature is the same. So we are passing the session and the URL and the method hit. Then we got the response status. This is the same, but let's just quickly implement this async get new request. What's the wording here? Nothing. So just quickly implement this async get request. So as the async def get request, the signature is that it has a method. So it's accepting the message. It's a string type. It has a URL. It's a string type, and it has a session. Again, it's aiohttp client session type, and it has a headers, which is a dictionary type, and the default is none. So what returns is a client is a aiohttp client response. So we are accepting client session and returning the response, as similar with sequential downloader. So there we have returned the request response, but here aiohttp client response. And what we have, we're checking that if headers, so if we did not pass, if we pass the headers dictionary into the get new request, we are going to update the user agent to string. Nice. And return the awaitable. So return the session. So we are doing the aiohttp session request with method equal to past method and URL equal to past URL, and the headers equal to the headers past headers. Nice. So get new request, not request. Get new request. Yeah. Nice. Then we what we have here. So we do the main. We have this check here. If response status, if response status greater than, and we are going to raise this exception. So not status code, but status, right? It's a status. Then we need to get the size of the size from the header. So from the response headers, again this is the same. So get with content length and print this size. Initializing the list of lists, this is the same as previous, and printing the sections is the same as well. Printing the sections is the same. This for loop also is the same. Let's just type for. What happened here? Yeah, nice. And this print sections is also the same. It's just me. I just copy it here. Then we're going to implement. Yeah, we need to create a task, asynchronous task from this from this download section function, asynchronous code. So what we have here is just for index and section in enumerate from the sections. We need to append to this tasks dictionary async io create task download section. We are going to quickly implement it here. So let's just implement it here. So what we have, let's just complete it here. So download section is going to accept this index, section, data, and the aiohttp session, and we are returning. We are returning these as sections and as well as tasks. So what we have, so we pass this empty list to the main function. The main function passes empty list to the do asynchronous function, and then we are appending the asynchronous tasks into this list and returning from the do code, asynchronous do function. So we have implemented the get new request. The only remaining thing is I think is download section, and yes, the merge file function as well. So let's implement this download section. Async def download a section. So it's accepting the index. It should be integer. It's accepting the session. It should be aiohttp client session. It has data. I assume it's a dictionary type, and no, section first. No, just oops. I'm going to grab it here, and it has a section which is a list type. Nice. Great. Then we are going to update the headers as usual with by giving the byte range here. So section 0, section 1 bytes, and the headers is a range. We are doing the get new request, but now we are waiting because this is asynchronous code. We get this response, and we need to print it. Right. Nice. So what's the next? The next is, as usual, so creating this creating this. Yeah, is writing to this temp file. So I'm going to create a file name, but there's this difference between the sequential code which we run. So what's the downloader? So here we are just using the pure Python open function, so built-in open function to write to the file. But this is a blocking action. That's why we need to asynchronous file write and read. So for that purpose, we have the special package called IO files. So we can't just open here the file and write into its response content as we did in sequential, because it will block. And if you have some blocking code, that means that there's no asynchronous code run in this context. How to say? Let's just read the data. So the data is awaiting response content read, because the response itself returns the awaitable. We need to read this response with await. So it's a coroutine, and we need to wait here for data. And just for opening and writing to the file, we are going to await IO files, open this file name, and again write a byte here, and then await fwrite the data, and then await fclose to close the opened file. This is how you write read and write to the file from the response. And so we read the response content asynchronously, we open this asynchronously, and write into this, and then close. So it's a non-blocking action. What we have next, what we left actually. So what's duplicated code? Nice. I don't care. The remaining thing is this merge files. So we run this in asynchronous asyncio loop past the main. I have completed the downloading all sections, and now it's time to merge the file. But this is a non-asynchronous code, so we are just plain merging the file. So opening this target path with WB, but plus it means that we will append the bytes to the file. So this is a final file. We are going through these sections, opening file, and write write the bytes to the final file, which is target path, which is this is a final file, and we have this with it will close as a file for us. That's actually yeah, finally we have completed, I assume. So let's just recap. So we implemented the do function asynchronously. We are waiting from get new request. We are creating this tasks and appending to the list of from the download section asynchronous code. So with get new request, we are using aiohttp instead of the request module, and we are using async IO to run this asynchronous code, and we are using IO files module to write to read and write into the file asynchronously. This is how we can implement the download manager asynchronously in Python using aiohttp, async IO, and IO files. Let's just I'm going to test this code, but first of all I need to remove this section things and this 5 MB. zip file. So what as output, what we have here, so as you see, there is no sequential runs from the over sections. It's the same thing should happen for the Python code as well. So let's just run it. Making connection. Nice. So we did a connection. We got the response code. We divided it into the chunks, and there is no sequential run for the Python code as well. So process finished. Let's just see LTHR. Yeah, we have the same file, the same size, and also the temp files are there also. So we have asynchronously download the file by the portions, by the chunks, but the synchronously merge the files, and we have a final file as well. So this is a real world again example how you can do some asynchronous code with concurrent code with implementing the downloader with Golang, and this is to show how you can translate the same idea to the Python with some asynchronous code. So that's it for now, and I hope it will be helpful to you. In the next videos, we are going to do the same again, concurrent programming, but with different ideas, for sure. And yeah, see you in the next video. Bye.